Oh, there, we're on. Oh, there we go. We're on. Okay, so our objective today is to find quadratic equations from 3 or more points. Okay? So we know that we have a vertex form. And the vertex form is nice. I like vertex form. If I've got a y equals some a x minus h squared plus k, vertex form is slick because you've automatically got the vertex right there in front of you. Makes it easy, okay? And then you've got our what we call our root form. And a root form is going to be some y equals a times x minus r1, that's root 1, times x minus r2, that's the second root. Now with these two forms, there is a third point. There's always a third point because of the form it's in. Vertex form, because of symmetry, once you find another point, you can flip it over and get 3 points. So you always need 3 points, always. Root form, you've got 2 points because of symmetry, you can get a third point, okay? You can always get a parabola from 3 points. But if the 3 points are just random, then we're going to have to use some technology. So we did this one yesterday. If I graph this, first of all, speed down here, and I've got my calories burned here. I might go 2, 4, 6, 8, 10, 10, 12, 14, 16, 18. That might not work because I got to get to 30. So maybe I'll go by 5s. Change my mind. I'm going to go 5, 10, 15, 20, 25, 30. There, I changed my scales. 5, 10, 15, 20, 25, 30. Kind of sloppy. My bad for changing my scales, okay? I'm going to do a squishy. Do you know what a squishy is? I'm going to compress everything from 100 down. So all of the numbers from 0 to 100 have been squished. And so then I'll go 100, maybe I'll go 110, 120, 130, 140, 150, 160. Okay, so I just did a squishy. Boy, my numbers are... I sure will.
Thank you.
Yep. I might even tidy things up while you're getting caught up because it looks pretty sloppy, doesn't it? Because I changed my mind, so maybe I'll come through and tidy this up, make it look better, huh? So I'm just going to do a dot to dot 12 and 152, about there. 22 and 105, about there. And 30 and 165 is about there, okay? Lexi, how am I doing? So then, I don't know, I can probably try and draw one in, but you know, it's like just a guess to get all 3 in here. I mean, it might even go like that. I'm not sure, right? So I find my quadratic model. To do this, I need to go ahead and put it in my calculator. So I'm going to make my matrices. But before I do that, I need to make my 3 equations. So we need to make our 3 equations. Yeah, I need to make my 3 equations using our ax squared plus bx plus c equals y, right? So I'm going to make my 3 equations. Stop me if I get going too fast, please. Luckily we did this yesterday, so this is a nice review, and we made the equations the day before. So equation 1 is going to be, if I put in 12 for x, I get 144 a put 12 and 4x, I get plus a 12b plus a 1c. And I like to put the 1c here. I like the 1 so when I put it into a matrix, I know what to put. I like the 1, and that equals my 152. Equation 2, so it's made from point 1. Equation 2 is made from point 2, right? So I'll put in the 22. 484a, that's 22 squared plus 22b plus a 1c equals my 105, right? And then we'll make point 3 from equation 3 from point 3. So equation 3 will be 930 squared a plus 30b plus a 1c equals 165. Okay, so we made our 3 equations, and then 2 days ago, on Tuesday, I made you do it the long way, and that was kind of a pain, right? Yeah. So now we know we can do it. Does it appear quadratic? Yes, I would say definitely it appears to be quadratic. Yes, I agree with that. I can kind of see the parabola in there. And it makes sense because a bird can soar and use less energy, but when a bird hovers, it uses more energy, but when a bird's going fast, it burns more energy. So right down here is probably where the bird's gliding, right? Which should be faster than hovering. Okay, so then, to do this, we're going to create 2 matrices. So we're going to use our matrix. We're going to have matrix A. And matrices are just boxes that hold numbers, and our calculator can put those in there. So I'll go 144, 12 and 1, 484, 22 and 1, and 930 and 1. Okay? So I create the matrix so I can put it in the calculator. The calculator wants the numbers. It doesn't really care about the variables. It just wants the numbers. And then matrix B is the answer matrix, which is going to be my 152, 105, and 165. Now the directions we took yesterday, and they're already posted up on YouTube if you want to watch the directions, but I'm going to go through it again, okay? So we need this. We need eventually, this is what we want to put in our calc, we need this A inverse times B to get our answer. That'll give me my answer, okay? And I will highlight that in a second. That'll give me my answer, okay? Hi, Emily. You have this probably from yesterday, I think. I passed that out.
Yes.
So I'm going to highlight this, and then Valeria says that you guys are coming in at lunch to take a retake. That's what she told me.
Okay.
Okay, good. I like that. So then, I'm just going to put that in my calculator. First, I have to create matrix A, right? So I turn it in, clear. I go to matrix, which is in blue, second matrix, right? I go to blue. I go to edit, and I think they are, oh, I got a different calculator. They're not in there. That's right. Enter, enter. So I'm going to put in my 144, my 12, my 1, 484, 22, 1, and then 900, enter, 30, enter, 1, enter. Okay. I've created matrix A, right? Am I going too fast?
Yeah.
Okay. And then you can either do the calculator piece if you want to, or you can just follow along. It's up to you, okay? Whatever you want to do. I think you know how to do that. Give me thumbs up when you're ready. Okay, Emily? I'm not Emily, I mean Lexi. Okay, good. So then I'm going to go ahead and create matrix B. So I edit. Everything's about editing. I want to edit B. I highlight B. I want to edit B. B is a 3 by 1, and I want to put in the matrix B, which is the 152, 105, and the 165, right? And then I quit because I don't want to, I want to get out and come back in. I like to hit quit, not clear, because clear number, so I quit. I want to create this, so I got to go back into matrix and find matrix A. There it is. I found matrix A under names. That's the one I made, right? That's the one I made. Boom. I want that. I want the inverse symbol. I want that inverse symbol, so that's right there. I want times. And I need matrix A, matrix B, which I'll find that in my matrix. I'll go back to my matrix. There's matrix B. That's the one I made. I don't have to recreate it. It's already made. That's the matrix I made. Enter. And when I push enter, I'll get the value of A, B, and C. So A, B, and C. A happens to be my 0.67. B is my negative 27.7. And C is my 387.3. Now, if that's A, B, and C, let's get an equation. So my equation then is going to be my y equals 0.67x squared minus my 27.7x plus 387.3. And then yesterday, what we did with that is we found the most efficient speed for the bird using negative b over 2a. And so then we were able to find out how many calories it burned. Okay, so we did that yesterday, okay? How am I doing? Okay. I can also then put this into decimals or into my calc, and I can actually find the equation, okay? All right, turn the page. Now, what if there's more than 3 points? If there's more than 3 points, we need a different way to do this, because we're not going to make a matrix with all these points. We're actually going to use the stat button instead. So we're going to use the stat button if there's more than 3 points, okay? The stat button's not that difficult either. So let's try and do a scatter plot first, okay? We're running the 400. That's something I like. And we got a whole bunch of times here and ages. So this is going to be my age. I'll go probably, let's see, 10, 20, 30, 40, 50. I can go by fives. 10, 20, 30, 40, 50. That should fit. 55 is right there. And then times, let's see if I go by 10, 20, 30, 40, 50, 60, 70, 80, 90. Yeah, I can just go by tens. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120. And I can do a scatter plot, okay? So this is time, and this is age, okay? Unfortunately, as an old man, I know that it's you young bucks that can run fast, and I can't anymore. It happens. Oh, well. So, and we also know that if you're really little, you can't run as fast as the big teenage boys or girls, right? So let's do a scatter plot. So age 10, about 112, might be about there. 13, we're going to have an A 75. Let's see this, 60, 70, 75. 15, age 15, about a 65, is right about there. 18, age 18 is 57. 22, age 22 is going to be about a 53, maybe there. Age 30 is going to be 70. We're starting to get old and slow now. 50, 60, 70. And for actually, the world records are about 30-year-olds, but these are the people that continue training in the Olympics, right? 41 is about 95, maybe right about there. And then 55, old dudes, about 125. Okay. Now, if you were to try and draw a curve in this, it's just not going to hit all the points. Agree? I mean, there's just no way it's going to hit all the points. So the best we can do is try and fit a quadratic curve to it. So when we do this on the calculator, the calculator is just going to try and put them all together, right? With 3 points, I'll turn it over for just a second. With 3 points, you can get the exact equation with 3 points. This will hit every single point. But with a lot of points, we're going to miss some. So what do? Well, we put it into our stat button. So we're going to go to stat. Okay, so I go clear, I go to stat, edit, you agree, edit. So stat was right in the middle top, right there. So stat's right there. Edit, always edit if we want to create something, right? So definitely edit, so we want to go to edit. So I'm going to hit enter for edit. And I've got, for me, a list 1, list 2. Anybody have numbers in their list? Okay, so you go to clear your list. Are you watching? you go up to your list and you highlight your list name, okay? You go up and just highlight your list name, push clear, and then down arrow. Clear your list, okay? Did it clear your list? Okay, and on the other list, you can go up and you can hit highlight your list, highlight list name, push clear, down arrow clears your list, okay? Everybody have 2 columns cleared? Do you remember? And also, I'd like you to remember, mine's in list 1, list 2. That's important you know where you're putting your numbers, okay? I'm in list 1, list 2. So I'm going to let age be list 1, which is like your X's. And I'm going to let seconds be list 2, which is like my Y's, okay? So I'm just going to start typing in my numbers. I'm going to go 10, enter. So I'm going to enter data. Okay, so enter data. Enter data. I did have to clear my list. Clear list. Enter data. So I'm going to enter data now. Thanks, Lexi. Keep me honest, huh? 10, enter. 13, enter. I'm doing list 1. 15, enter. 18, enter. 22, enter. 30, enter. 41, enter. And 55, enter. Okay. And then I'm going to enter list 2. So I just move my arrow over list 2. Am I doing okay?
1 sec.
Okay. If you get stuck, please ask. Okay. If you get stuck, please ask. Okay. List 2, 112, 75, 65, 57, 53, 70, 95, and 125. Okay? Okay, now, I'll wait for you. Give me thumbs up when you've got all the data in. Okay, 1 thumb up. Anybody not got the data in? Okay. Angela, you good?
Yeah.
Valeria?
Yeah.
Charles? Reese, are you ready? Are you ready? Okay, so now, we're going to go back to stat. We're going to go back to stat, because within that stat button, now we can calculate an answer, okay? So go back to stat. We've already edited our data. So now we want to calculate an answer. So go back to stat. I'm going to go to calculate, okay? So I'm going to move it over. And what I'm really going to look for is this quadratic, right? I want the quadratic. So you could get a lot of different equations, but the one I want specifically for this is the quadratic, because it is a quadratic regression. It's a parabola, right? So I'm going to go to quadratic, which stands for regression line. Enter. Okay, push enter. Now every calculator is different because there are like 3 different models. Okay, so who's got the old calculators, those old purple beat up ones? Nobody does. So that's good. So I'm going to go down to, I've got list 1, list 2. I like that.
Quadratic?
Yep, quadratic. And then enter. And then I'm going to go to calculate, right? Am I going too fast?
Yeah.
Oh, my bad. There you go. There you go. So I went to quadratic, pushed enter, and I'm right here. And you may have a different screen. If you do, that's okay. I can help you because they're all different. The newer ones do this. And I'm going to push enter again on calculate, okay? Enter again. And it's going to give me my answer, okay? I'm going to push enter again. It gives me my answer. So I've got A is about a 0.09. I've got B is about a -5. C is about 129.9. Did you get those values? Now mine showed an R squared value. You don't need this, but the R squared value tells you how good your points line up. If this is at 1, which is 100%, that's awesome. 1 is awesome. It means I got perfect curve. All of my points are on my line. It's like saying about 73% of my points are on the line. It's okay. I don't have very good data. I just grabbed a bunch of kids off the street and I made them run, right? So, yeah.
Isn't R our correlation coefficient?
Yeah, R is your correlation coefficient, right? Very good. Yes. So then, what's your correlation coefficient? R squared. is about a 0.729. And then we'll find R by taking the square root of that. Okay. So then, before I do that, I want to write my equation because my answer is really this. Y equals a 0.09 x squared minus a 5x plus 129.9. Okay. And then if I wanted the R for the correlation coefficient, I'll just take the square root of that. Clear, I'll go square root of my 0.729, and I get an answer about 0.85. So it's not as bad. My R is about 0.8538. Not a terrible R, but not a great R. Okay, then finally, well, the fastest age according to my data sure looks like the 22-year-old's fastest. You guys agree?
Oh, yeah.
Right? 22-year-old looks like the fastest age. But if we take our model, let's see what our model says. So we'll use our negative b over 2a, right? Which is our negative 5 over 2 times my 0.09. And so I'm going to go 5 divided by parentheses 2 times my 0.09. And there seems about 27, according to my model, it'd be about a 27.7-year-old, which actually makes more sense. That is about your prime for a sprinter. It really is. What's that time? How do we find the time? Plug it in, yeah. So to find the time, I'm just going to plug it in. I'm just going to go y equals 0.09 times 27.7 squared minus 5 times 27.7 plus my 129.9. And I want to show you something cool. Watch, watch, watch. You want to see something cool? I'm going to show you something, okay? There is a button on my calculator called answer. See it? A-N-S, answer. So when I do this, you're going to go, whoa, I didn't know that. 0.09 parentheses answer squared. I don't have to retype that number. And it's more accurate, isn't it? Answer squared minus 5 parentheses answer. Love that answer button. And then plus 129.9. And then it saves me time and it's more accurate. So they got a time of 60.45, which is not accurate, right? So because our time up here is faster, right? So what does this tell me about this? What does this tell me? What does this tell me? I've got a time up here that's faster, but my model has this time. What does this tell me? It's obvious. How good is my data?
Bad.
Right? I mean, I just took a bunch of dudes off the street and made them run, right? So my data is not great. That's what it tells me, okay? So if I were a true scientist, what would I do? I would do the experiment again. I'd find some other random people on the street and make them run.